Hi, welcome to Great Power. This is the digital battery production, where tons of batteries are being churned out as we speak. Before stepping inside, we all suit up in these cool anti-static suits. Why? Well, they prevent any anti-static electricity from our clothes rubbing together and messing with the gear and the products. Plus, it keeps out any pesky dust or junk, making sure the whole production stays squeaky clean. Okay, as we walk through this corridor in the workshop, let me tell you something. The whole workshop maintains a constant temperature and humidity. These factors really impact the stability of the raw materials for the batteries we produce. If the temperature gets too high or too low, it can mess with the material's property, affect how quickly reactions occur, or even change the chemical reaction happening inside the battery, which in turn affects the performance of the battery. High humidity might cause corrosion or nasty chemical reactions inside the battery, damaging its performance and lifespan. Low humidity can make the materials really dry, making them unstable or prone to damage. That's why during production, we are super strict about keeping the temperature and humidity in the workshop just right. We ensure the raw materials stay constant and the whole production process is accurate and uniform. Our goal is making every single battery cell coming out of this production to have top-notch safety, long cycle life, and high energy efficiency. This production here covers all the steps of battery process. What you see now is the screw mixing process, where we pour all the active materials, conductive, agent, powder, binding solution, solvent, mix them all up using the screwing machine. Then comes the scrapping and filtering. Once these materials are dispersed and turned into slurry, they undergo demagnetization and are ready for the next process. This demagnetized slurry is transported through pipes to the coating workshop. There it gets evenly applied to the electrode sheets based on the customer's requirements. We do both sides and measure the surface density after coating and baking. And guess what? All these tasks are controlled in real time by computers and fully automating the production process. So, in this part of the process, we're rolling these electrode sheets. It's pretty much like you rolling out dough, but way more advanced. We've got these fancy machines that control tension and use lasers to measure the thickness. What's cool about this step is that it serves a couple of purposes. First, it thins out the electrode sheets, making them smaller, but packing more power for the battery. And second, it smoothens the surface, preventing any hiccups that might cause the battery to short out. Once these sheets are all rolled up, we use another machine to cut them into sizes our customers need. This machine's got lasers for cutting out these tab shapes, and it's got other steps like aligning, cleaning off any dust, and getting rid of any magnetic stuff. Then we've got these machines that wrap the electrode sheets around the separator. It's like a battery making a dance. There are a couple of ways to do it, but this method is called winding. It has been a hit. It creates the core of the battery by rolling everything together. We add codes so that we can track them down later. After that, we move to the heat and processing assembly. The battery gets a good test for heat and power to make sure it's all up to par. Once that's all set, it's scanned and logged in our system. Finally, we put the battery into its casing, getting it ready for the welding stage. But before that, we test the battery multiple times to make sure it's top-notch. We're going to use two types of welding, ultrasonic and laser welding. Ultrasonic welding attaches the tabs to the lead terminals, while the laser welding connects the pieces with the top cover. It's full cover welding. This involves using continuous laser technology, completely fuse the top cover and aluminium shell, ensuring high sealed interiors, exceptional pressure resistance within the battery. By now, these batteries are starting to shape up. The next steps will turn them into something really usable. Want to see how we inject the stuff into them? Come on, let's check out the injection room. Injection is about pumping in electrodes into these batteries, and it's a two-step process. First injection, and then the second, the electrodes, like the battery's blood, helping ions move between the anode and the cathode of the battery. That's what gives us electric juice when charging and discharging the battery. All right, it's time to wake up the battery. Once we finish injecting the electrolyte, the batteries are transported using the mechanical arms of the fully three-dimensional storage. Then we feed the batteries with a current to initiate the first charge. This process simultaneously creates a dense and stable solid electrolyte interface. SEI layer. This SEI layer prevents damage caused by solvent molecules embedding into the electrode material, improving the battery cycle in performance and lifespan. We call this forming. To top up any lost electrolytes inside during production, we usually give them a second round of injection. It's pretty much like the first one. After that, these batteries are technically good to go. But wait, there's more in the production. They need to pass a couple more tests. First, there's a helium leak test. They use this machine to make sure there are no leaks. That's like checking if the battery seal is tight. Then it's time for capacity testing. See these tons of batteries here? Each one gets its own test. They get charged, discharged, and measured how much power they hold. When all juiced up, that tells us how strong they are. We jot down every single detail about these batteries on the computer. Finally, the last step. After they've checked for their power, they are wrapped in this blue film. We use a fancy EMS to sort and pack them before they're shipped out.